Hello. Well, in the last few days we've started to witness an interesting astronomical event called a supernova. It's just been categorised as SN 2014J, and it's in a nearby galaxy called M82, or the Cigar Galaxy. Now, the event actually happened about 11 million years ago, but we're only just starting to see the light now, and it should continue to get a little bit brighter over the next few days, and could be one of the brightest supernovae we've seen for quite some time. In this video I'll be telling you where to look for the supernova, and then a little bit about supernovas and why they occur, and then why scientists are particularly interested in this particular supernova. In order to be able to find SN 2014J, you're going to need to be able to find the galaxy M82. To start off, locate the Plough or the Big Dipper. It's part of the Ursa Major constellation and it's near the North Celestial Pole. Draw an imaginary line between Gamma and Alpha Ursae Majoris, diagonally across the bowl of the Plough. And if you trace that line roughly twice that distance, you will come to the approximate region of two galaxies, M81 and M82. There's a slightly better approximation. If we go approximately halfway, then you will find a small star which is only just visible to the naked eye, and in fact there's two stars close to each other. From Alpha Ursae Majoris, go on the line about halfway in between these two stars, and you will eventually come to M81 and M82. M82 is the galaxy closest to the North Pole. In a small telescope, the galaxies will appear as fuzzy patches. In a larger telescope, you'll be able to see some structure. The supernova lies just off to the centre of M82 and will look like a bright star in the plane of the galaxy. So, this particular supernova is likely to peak at about magnitude 9, roughly. So the magnitude scale is a logarithmic scale, and the lower the magnitude, the brighter it is. Now, magnitude 9 is a little bit too faint to see with the naked eye. However, it should be visible in a decent pair of binoculars, and certainly in a small telescope. There'll be an opportunity to see it for quite some time, although it will start to fade as the weeks and months go on. So what actually is a supernova? Well, in simple terms, it's an exploding star. A star that blows itself to smithereens at the end of its life. A supernova can get extremely bright. In fact, a supernova can briefly shine as brightly as the entire rest of the galaxy put together. I mean, there are estimated to be around 100 billion stars in our Milky Way galaxy, and to think that one single star can shine as brightly as all of those for a brief period is amazing. It's an enormous power output, and that's why they can be seen from so far away. Now, there are a couple of main types of supernova. There's the type 2 supernovae, which is where an enormous, massive star reaches the end of its life, and, well, most stars are basically, they've got radiation pressure, all the light is pushing outwards and balancing the force of gravity, trying to collapse the star down to a point. But in an extremely massive star, when they start fusing heavy elements like iron and nickel, they can no longer produce the outward pressure needed to support the huge mass of the star against gravity, and it collapses inwards on itself and explodes. In a type 1A supernova, it's actually a very small star, although very dense. It's called a white dwarf. Now, this is only just a little bit more massive than our Sun, but compressed into perhaps something maybe only the size of the Earth. So extremely dense. You know, a teaspoonful would weigh a few tons. And this isn't actually held up just by radiation pressure. This is actually held up by something called electron degeneracy pressure. But above a certain mass, this can no longer hold the star up against the force of gravity either. And it's above about 1.4 times the mass of our Sun. It can no longer support its own mass, and it explodes as well. Now what usually causes this is when two stars are going round each other, you know, a very dense white dwarf and a much bigger red giant star. And what can happen is material from one of the stars can start falling onto the white dwarf, gradually building up the mass until it reaches that critical limit called the Chandrasekhar limit, and then we have a supernova. And it looks like this one in M82 is a type 1a supernova. This is actually the brightest type, and it's quite interesting because most type 1a supernovas tend to get to a very similar absolute brightness. So if we know how bright they got at their peak as seen from Earth, then they're usually very good at determining just how far away they are. So they're sometimes called standard candles. This is actually one of the first times in recent years that we've had the opportunity to study type 1a supernovas from this close. Now, although 11 million light years might seem like a long way away, it's actually relatively close on the scale of supernovas. They're relatively rare events. They're estimated to occur roughly once in a large galaxy every 100 years. So it's a good opportunity to study one up close. It's probably the closest supernova we have seen probably in about 27 years since supernova 1987A, which was seen in one of the Milky Way's satellite galaxies called the Large Magellanic Cloud. So that's one of the reasons why most scientists are potentially quite interested in this supernova. It's a great opportunity to study this type of supernova from a relatively close point. We haven't actually seen a supernova in our Milky Way galaxy for about 400 years. Now, one of the problems is that when you live inside a galaxy, a lot of the middle of the galaxy is actually obscured by all sorts of dust and gas, and we don't actually see everything very well. And sometimes we actually get a better view of other galaxies. So, thanks for watching.